Hello, thanks for clicking. Welcome to another Argulus 2 production. Today we're going to be learning about parametric equations. Okay, using an additional parameter within an equation to define x and y, or two variables, in terms of a third variable now that we're going to introduce. All right, so let's get started, see how this works. It's not as difficult as one might think, and hopefully it's pretty intuitive. So let's take a look. So let's talk about x is equal to some function f of t, and y is equal to another function called g of t. There are two functions in terms of a third variable, t. Okay, t is referred to as the parameter of this function, all right, or of the equation. Okay, and the two functions together are called parametric equations. All right, so what are we talking about here? I think the idea that's easiest to understand is if you, let's say you considered t to be the variable time, right? So t is time. Basically, what I'm going to do is I'm now going to be able to graph some equation, whatever it would be, in terms of time, meaning that I can pick a specific value for t. Let's say t equals 1. And at t equals 1 second, I can figure out the location of something, or the location of that equation, or something that's on that equation, like a particle, okay, where it is on the x-axis and where that particle would be on the y-axis as well at that time called t equals 1. All right. That's really what it is that we're looking at. That's the simplistic version of what it is we're trying to do. Okay. And in a moment, we're going to graph a plane curve. A plane curve is the graph of all points x, y, given by x of t and y of t. All right. We're going to graph a plane curve. All right. So let's take a look and try to graph a plane curve. This is just a very basic introduction to parametric equations. Okay. So here are some parametrically defined equations. X equals t squared minus 3, and y equals t plus 2. For t between negative 3 and 3 closed. What I want to do is I want to sketch the equation, and I want to sketch it with direction. So we're going to talk about direction in a minute. Now, to sketch this thing, what we're going to do here is we're actually going to plug in values of t. Okay, so it seems pretty tedious, but we're going to do it for the first time, just that we kind of get an idea of how this whole thing works. So we're going to plug in all these values of t. Now, when I do that, if I plug in a value of t, it's going to give me an answer for x, and it's going to give me an answer for y. And then that's going to give me an ordered pair x, y. It's going to give me my x location when t equals 3, and it's going to give me my y location when t equals 3. Okay, and then I can plot that point on my coordinate plane. So if I were to substitute t equals negative 3 in, just to do it, we'll do it the first time only, and then after that we'll kind of do it figuring it out. So without writing it, so negative 3 squared is 9, 9 minus 3 is 6. If I plug t in for y, I get negative 3 plus 2, that's negative 1. So the coordinate point would be 6, negative 1. Okay, so now that's the idea. So let's just fill out this chart real quick. If I plug in negative 2 squared is 4, 4 minus 3 is 1 for x, negative 2 plus 2 is 0 for y. That gives me an ordered pair, 1, 0. If I plug in negative 1 squared is 1, 1 minus 3 is negative 2 for x, and then negative 1 plus 2 is 1. That's the point negative 2, 1. If I put 0 in, that's negative 3, and that's 2 for y, negative 3, 2. If I substitute 1 in for x, I get negative 2, and 1 in for y gives me 3, negative 2, 3. If I substitute 2 in, I get 1, and 2 in 4 for y, 1, 4. 3 gives me 6 for x, and it gives me 5 for y. Now, all of these points I can graph. So I'm going to graph them, and then we'll talk a little bit about direction. So 6, negative 1. Well, I got to go I don't have 6 on my graph, so I'm going to make it over here, okay? Hopefully that's okay. I'm sorry. Don't have it here, but we can make it. So we got 6, down 1, put a point there, and then we have 1, 0. So right 1, and then -2, 1. There we go. And we have -3, 2, -3, up 2, -2, 3. We have 1, 4. And then we have 6, 5. So we have to go over 6 again, up 5. Now, if I connect all these, right, all these points, it makes a curve. This curve is called the plane curve. All right. There it is. Now, notice a couple things about it. This thing is not a function, right? It doesn't pass the vertical line test at all, okay? But now what I want to do is I want to sketch the equation. So we did that, but it says to sketch the equation with direction. So what does that mean? Well, again, think about these t values as being time, right? This is the value here. This point is when t equals -3. Here's the value when t equals -2. Here's the value when t equals -1. Here's the point when t equals 0, t equals 1, t equals 2, t equals 3. So now, can we show somebody what direction, let's say if I had a particle moving along this curve, what direction the particle is moving? Well, yeah, as t increases, the particle is moving this way and around that way and back that way. So we're going to do that with these arrows. Okay. This is the curve or the plane curve with direction. All right. It's showing me which direction a particle or whatever it is would be moving in terms of, let's say, t, some variable t, or, in terms of time or whatever that may be. Okay. That's what a parametric equation or a plane curve looks like. All right, so now, finally, or not finally, just about, consider the parametrically defined equations x equals t squared minus 3 and y equals t plus 2. The question is, could you eliminate the parameter and write this equation in terms of x and y? Well, yeah, it's actually pretty easy to eliminate the parameter. I'd have to eliminate t, but there's 2 equations and both have t in it. So if I take the y equation and subtract 2, I get t equals y minus 2. And if I take y minus 2 and substitute it in, got to write it correctly. We have x equals y minus 2 squared minus 3. I just eliminated the parameter. Okay, I can multiply this out if I wanted to, right? I could. I'm not going to, but I could. All right. So I've just eliminated the parameter. The parameter is gone. This thing is now in terms of x and y. Okay, and you can see that this would not be a function if you were to solve it for y. Right? You take the square root on both sides and you plus or minus. So you'd have 2 branches, a positive branch and a negative branch. So you'd have 1 branch up top and 1 branch underneath. So that would not be a function. Okay, but that's how you eliminate a parameter. Solve one of the equations for the parameter and then substitute it into the other. All right, and then finally, we have a definition here called a smooth curve. A smooth curve is a parametric curve if x equals f prime of t and y equals g prime of t are not both 0 at the same value of t. Okay, it means that the curve will not have any corners or cusps. All right, so we're back on that, the concept of differentiability, right? Back from the beginning. If a parametric curve does not have any corners or cusps, or the derivative of f and g are not both 0 at the same value of t, we're going to look a little bit about derivatives in the next video. We consider that curve to be a smooth curve. All right, and that's just a definition that you should know. Okay, that's it. As always, thanks for clicking.